Hi, hello, my name is Syafira Widiyanti with student number 123200057. I'm from class H, and today I will present about data analysis of 5th semester mathematics course list at SMA N1 Bantul. So the first one is descriptive analysis. What is descriptive analysis? It is used to describe or summarize the characteristic of data. Several measures can be calculated besides identify its frequency, such as variables mean, median, mode, standard deviation, and so on. So these are the formulas to find the mean, median, skewness, variance, standard deviation, and kurtosis. This is the result of the descriptive analysis of my data. The mean of the data is 85.89, with the standard error is 0.237. The median of the data is 85, and the mode is also 85. The variance is 11.331. The standard deviation is 3.366. The minimum of the data is 77, while the maximum is 95. We can find the range by subtracting the maximum value with the minimum value, and we found the range is 18. The skewness is 0.184, and the last is kurtosis, it is minus 0.082. You may wonder what is skewness and kurtosis. So skewness is a degree of distortion from the symmetrical bell curve or the normal distribution. And kurtosis is a statistical measure that defines how heavily the tails of distribution differ from the tails of normal distribution. So let's take a look at the skewness curve. And this curve shows that the data is normal because the mean is almost the same with the median and the mode. It's just slightly different. It's just about 0.89 difference. We can say the data is symmetrically distributed. As we can see here, the mean is 85.89. The standard deviation is 3.366, and the amount of data is 202. Because the median and the mode is 85 and it's just almost the same with the mean, so the curve is normal. Okay, so next is data distribution. Data distribution is a listing which shows all the possible values or intervals of the data. And the data in a distribution will be ordered from the smallest to the largest, and graphs and also the charts allow you to easily see both the values and the frequency with which they appear. So the first one is frequency distribution table. To make this table, you need to make the intervals, and you need to find the number of classes and also the class width. And how to find the number of classes? You can use the formula 1 plus 3.3 times log total data, which in my case is 202. And I found the number of classes is 7. And we can find the class width by dividing the range 18 and the number of classes 7. And it results the class width is 3. So as you can see here, I have 7 number of classes or 7 intervals, and each interval has 3 values. I start the first interval from 76 and end it at 96. As we know that from the descriptive analysis, the minimum or the lowest value that I have is 77, and it's included in the first interval. Also, for the maximum or the highest value is 95, and it is also included in the last intervals. It is allowed not to use the minimum value as the first number in the first interval, You can use other value before the minimum value, but you have to include the minimum value in the first interval. This is the absolute frequency. We find the frequency for each interval from the data that we have. The frequency for interval 76 until 78 is 3. The frequency for 79 until 81 is 13, and so on. And if we sum all the frequencies, the total will be 202, which is the same with the amount of our data. And the third one, this is the relative frequency, which in the percentage form, by dividing the absolute frequency with the total and multiple with 100%, we will find these relative frequency values. And if we sum all the frequencies, the total will be 100%. The middle value is gotten by adding 76 with 78 and divided by 2. In the other word, we find the average from each intervals. So for the first interval, the middle value is 77. For the second middle value is 80, and so on. Okay, next. So I made this two graphs. The first one is relative frequency chart, and the second one is absolute frequency graph. So I will discuss about the first chart, relative frequency. I made in the pie chart, and I used the data from this relative frequency. So we know that the highest or the most data is in the 84 until 87 intervals with the value 34.7%. The least or the smallest value is in the first and the last interval, 76 until 78, and 94 until 96 with the value 1.5%. And for the absolute frequency graph, I made the histogram and also the polygon, and I used the data from this table, the absolute frequency. Well, the highest value is in the 84 until 87 interval with the value 70. And the least or the smallest value is in the first and the last intervals with the value 3. Okay, so the second is normal distribution data. And to make the normal distribution data, we need the z-score and the probability density function. We can find the z-score using by subtracting the x with the average and divided by the standard deviation. And this is the formula for probability density function. And this is the chart of the normal distribution. And as we know from the chart, as we can see from here, the data is normal. Okay, so the third one is sampling distribution. Sampling distribution is a distribution of all of the possible values for the mean or proportion from a given size sample selected from a population. So this is the population distribution. We know that the mean is 85.89, the standard deviation is 3.36, and the amount of data, or the N, is 202. And this is the graph for population distribution. From the 202 populations, two representatives, observation 1 and observation 2, were chosen with replacement or sampling, and we found 40,804 possible samples. And from each samples, we find the average or the mean. So there are 40,804 samples mean here. From the table, we made it into this graph and calculate the average of it. The average of the sample is 85.89, which is the same with the average of the population. But the standard deviation is different. It's 2.37, and the sample's mean standard deviation is also called the standard error of the mean. And the standard error of the mean decreases as the sample size increases. We can compare the sample mean distribution with the population distribution, and we know that the mean of its population is the same with the mean of the sample. It is 85.89. But the difference is in the standard deviation. We know that the standard deviation of population is more than the standard deviation of sample. Like in here, the standard deviation of population is 3.36, and the standard deviation of sample mean is 2.37. And we found that the population is normal. Using the normal distribution chart, we know that the population is normal, right? So if a population is normal with mean of population and standard deviation of population, the sampling distribution is also normally distributed with mean of samples mean or X bar equal to mean of population or mu and standard deviation of samples mean equal to standard error of population. So look at this slide, population and sampling distribution. As I said before, the mean of or the average of sample mean is the same or equal to the average of population, and the standard deviation of sample mean is equal to the standard error of population. We know that the standard deviation of population is more than the standard deviation of sample, and that's why the curves here, the curve is a little bit different. The samples curve is taller and narrower than the population curve. And the conclusion is the sampling distribution shows that the mean of population and the sample are the same. It is the same with this equation. The mean of the sample is equal to mean of population, even though they have different amount of data, but they have different standard deviation. The more sample size that you use, the smaller standard deviation of sample. Okay, so the fourth one is the confidence interval. It is a range of values that describes the uncertainty surrounding an estimate. So confidence interval has two types. The first one is mean, and the second one is proportion. And we can divide mean into the standard deviation population is known and unknown. But in here, I will only explain about the confidence intervals of mean with both the standard deviation known and unknown. So how do we find confidence interval? If the standard deviation known, we use this formula, and if the standard deviation unknown, we use this formula. So X bar plus minus Z alpha per 2 times standard deviation per square root of n. The difference between these two formulas is the standard deviation. Okay, so I will explain the formula. The X bar or the point estimate is the sample mean. The Z alpha per 2 or the T alpha per 2 here is the critical value. And the standard deviation here is the standard deviation of population. And S is the standard deviation of sample. And N here is the amount of a random sample. And what is critical value? Critical value is a stable value based on the sampling distribution of the point estimate and the desired confidence level. For example, you use the confidence level of 95%. 95% is the same with 0.95, and that's the confidence coefficient. 0.95 is the confidence coefficient. And it means that 1 minus alpha is 0.95, and you can find the alpha by subtracting 1 with the 0.95. And the result is the alpha is 0.05. Remember, you have to divide the alpha by 2 to get a critical value. And you divide 0.05 by 2, and you will find 0.025. The 0.025 value is equal to 1.96, and that's the critical value of 95%. So this is how to find the confidence interval if we know the standard deviation. And I use the confidence level 95% here. Okay. So this is the population with n or amount of data 202. The mean is 85.89 and the standard deviation is 3.36. And for the sample, I use random sampling here with the amount of data 10, and this is the sample that I got, and the mean of these 10 samples is 8.86. So after getting all of this information or all of this data, we substitute the number into the formula. So we substitute the mean of the samples 8.86 into the x bar here, and the z value or the critical value is 1.96 times the standard deviation of population is 3.36. Here we put it in here, and per square root of n. N here is the amount of samples data. So we substitute 10 here. After that, we will find the lower bound limit. We use the same formula, but change the subtractions here into the addition, and we will find the upper bound limit. So it means that we 95% sure that the average of the population is between 84.72 and 88.88. And this is right because the mean of the population that we know is 85.89, and this value is between this lower and this upper limit. So this interval is true. And how about if we don't know the standard deviation of population, but we have to know the standard deviations of the samples? And we use the second formula. Well, it is actually the same. The z or the t is the same critical value. So just substitute the number that we have into the formula. We input the x bar is 8.86 and the critical value is 1.96 times or multiple by the standard deviation of sample 3.88 and divided by square root of n. N is 10 here, and the first is subtraction, and we will find the lower bound limit. It is 84.39. And if we change the subtraction into the addition, we will find the upper bound limit, 89.21. It's been that we 95% sure that the average of the population is between 84.39 and 89.21. And yeah, it is true, it is right, because the mean of population or the average of population that we have is 85.89. And it is between this lower and upper bound limit. So the interval is true. Okay, so the last one is hypothesis testing. Hypothesis testing is an act in statistics whereby an analyst tests an assumption regarding a population parameter. So the data that I use is the data of 5th semester mathematics course list at SMA N1 Bandung. And we know from the descriptive analysis, the average of population is 85.89, and the standard deviation of population is 3.36. And I pick the random sampling here with the sample of size and 100. And from the random sampling, I found the mean of sampling is 86.03. And I used the alpha here 0.05. And from the previous table, from the previous critical value table, we know that the critical Z values for the alpha 0.05 is 1.96. I use a two-tail test here, and I use critical value and the p-value approach to testing. Okay, the hypothesis test is the first is null hypothesis, or H0. The is equal to 85.89, and the second one is alternate hypothesis, or H1, is not equal to 85.89, and we make the test statistic using the Z. We have to find the Z value here using this formula. Just substitute the number that we already know, change the X bar here into the mean of sampling, 86.03, change the mu here into the mean of population, 85.89, and then the standard deviation of population that we have, 3.36, and divided by the square root of n, and examples of size, and here, and change it into 100. And then we calculate it, and we found that the Z value is 0.417. Okay, so draw the curve, and these are the critical region. This two green area is the critical region. And if the test statistic here, or the Z value falls in the critical region, or in the green area, it means that we have to reject the H0. Otherwise, if it falls behind or in the white area, we do not reject the H0, or we do not reject the null hypothesis, or it means that the null hypothesis is true. Or in the other word, if the Z value is more than 1.96 or less than minus 1.96, we reject the H0. So we already calculate the Z value, we already do the statistic, and we found that the Z value is 0.417. And because it is in the white area, or it is less than 1.96 and more than minus 1.96, it means that we do not reject the H0. We can see the decision here, we do not reject at alpha 0.05. And we got the conclusion, no evidence that true mean is not 85.89. Okay, so after finding the critical value, we find the p-value, or the probability, using the Z value. P with Z is more than or equal to 0.42. And how to find this probability? We are using the standard normal distribution table. We know that our Z score, or Z value, is 0.42, and how to write that in this table. So 0.42 equal to 0.4 is the row, and then 0.02 is the column. We can search the row first. 0.4 here. Let's take a look. 0.0, 0.1, 0.2, 0.3, and then this is the 0.4. And column, we can say this is 0.02 or just 2. So column 0, column 1, column 2, and we found that the probability of 0.42 is 0.6628. But this is the probability of Z is greater than or equal to 0.42. And to find the right probability, we have to subtract the probability with 1. So probability z greater than or equal to 0.42 is 1 minus 0.6628 equal to 0.3372. This probability is only for one side. And we tested this hypothesis testing using 2 tail tests. So we need to multiply the probability with 2. So the result of p-value is 0.6744 for both sides. Okay, so if p-value is greater than or equal to alpha, we do not reject the H0. But if the p-value is less than or equal to alpha, we reject H0, and we found that our p-value is greater than alpha. So the decision is we do not reject the H0, or we do not reject the null hypothesis. Or it means that the null hypothesis is true, both the critical value and the p-value. You can also connect the hypothesis testing with the confidence interval. So using this X bar on the average of sampling 86.03 and the standard deviation 3.36 and N 100, the 95% confidence interval is here using the previous formula. We have to find the lower bound limit and upper bound limit, and we know that the lower is 85.37 and the upper is 86.69. And if this interval contains the hypothesized mean of population, we do not reject the H0 or the null hypothesis. So we know that our mean or our average is 85.89, and it is in the interval. 85.89 is between this lower and upper bound limit. So it means that we do not reject the H0 or the null hypothesis. I think that's from me about the data analysis of the first is descriptive analysis, the second is data distribution, the third is sampling distribution, the fourth is confidence level, and the last is hypothesis testing. I'm sorry if I made lots of mistakes. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.